हेलो एवरीवन, कैसे हो सब। तो दिस कोर्स इज ऑन DBMS in one go, right? And it's not like our applied OS where we coded each and every example. We made 5 plus projects, right? This course is intended to make sure that you are able to crack DBMS interviews, DBMS rounds in your internship placements, or in general if you are making any project, you are aware how to choose databases, what aspects you have to take in mind before working with databases. So all these things will be covered in one go. And just to give you a TLDR, I will be going through theory, right? Evolution of databases, different type of databases evolved over the time, and what exactly a relational database is, what is non-relational database, and how they are storing things under the hood, like B+trees, indexing, hashing, schema of database, diagram. We will be designing some of the diagrams of Uber, of Instagram, and I will walk you through step-by-step process of how to collect requirements from the interviewer, how to revisit the requirements if you are stuck, and how to go with the flow, right? Flow means collecting requirements, then coming up with an idea, and then asking for feedback, and all these things process put into the place, and all these things are covered in this course, right? So without any further ado, I will start. But before starting this course will be around 3 to 4 hours. And for these efforts, you can like the video, you can share on Twitter so that other people can hop on over the video. So yeah, let's start the video. So a bit of theory, right? Why? Because see, databases in general are theoretical when it comes to choosing databases and all. But when you will go and make projects, you will get to know that how to use that theory, right? How to use the theory of diagram to make sure how to design your database for your project, how to come up with SQL or no SQL choice, right? All these things are related to theory, and obviously we will cover some of the use cases, some of the real world examples, right? So that you are not bored, right? Yeah, so let's start. So DBMS, what exactly DBMS means is that database management system, that is the full form, right? Database management system is a kind of way to organize the data, maintaining relations, giving types or names to data, and so much more, right? So what does this mean is key whenever you are dealing with database management system, it's not all about storing data, right? It's not all about that you store data in file and it will persist at that file forever until you delete, right? Until you modify. So it's not like that. Database is way more than storing the data into files or into somewhere, right? But few of the things are organizing the data. So it's not storing about the data, it's about how you organize the data, right? So yeah, one of the key thing is that, right? And then maintaining relations. So basically when your data is related, right? Let's suppose a student is related to his class, right? A student is related to school or a professor or a teacher, right? Then that relation you will be able to set up in database management system, right? And then giving types or names. Types means that let's say I have age of 25 years, right? My 25 years age can be represented as an integer, right? So the type of my age will be integer, right? Or if I'll say my name could be represented using text, right? Using string. So these are the types that will give you a structure to your data when you will store, when you will retrieve, right? So database management system is more about storing and retrieving the data. So some of the things are giving the types, giving the names, obtaining the relationships, and querying the data is also there. So why DBMS over a traditional file system, right? So this question is a very generic question that any interviewer can ask, why DBMS are present at the very first place, right? So why databases are there, right? When you have a file system, why databases exist? So basically file system is an interface over on top of your operating system calls, where your file write, file read, file append, all these things goes to, right? So this is a file system when you can open your folders, files, directories. So file system is basically maintaining folders in a hierarchical structure. What is hierarchical structure? We'll see. It's a very basic structure. It's just a flowchart, right? Whereas in file, one can store text, binary executable data, video, audio, etc. But file system lacks few things like relation, constraint, data type, inconsistency, and redundancy. So in database and management system, inconsistency and redundancy These both terms are very important. See, inconsistency, a very simple example for the time being is ki, let's suppose you have two files, right? Let's suppose you have two files, file 1 and you have file 2, right? File 1, file 2. So if you have written file 1 at the very first place, you have written file 1, right? You have copied file 1 to file 2, right? Now let's suppose in file 1 you write something else. Let's suppose it's a text file and you appended something. Let's suppose my name itself, Lovepreet. And if you have appended something here, it will not go directly to file 2. So this is what is called inconsistency. Means these two files are same. These were same actually. These files were same, but after appending something in file 1, it's not being reflected into file 2, right? So this is where the consistency is broken and inconsistency is there, right? And redundancy is basically when you are copying the files at multiple places, all those files, all those same files can coexist at the same time in different folders. And redundancy means duplicacy, right? When you are duplicating something. So the file system main problems are redundancy, consistency, and the second thing is you can't obtain relationship. Like let's suppose file 1 is related to file 2 by, let's suppose, relation R1. How to represent that? In database we'll represent that, don't worry, but how to represent this relation in file management system? You can't, right? So that is one of the con of file management system. Though it's a great interface, file system is a great interface for managing your files, managing your data. But when it comes to relationship, when it comes to giving data types like integer, string to your content stored in the file, so it has some down limits, right? So these points are explained in detail, like data redundancy and inconsistency. What does that mean is that let's suppose if user 1 wants to access the data, it might come from file 1, right? While same data can be duplicated in file 2. Okay, so the two files exist, let's suppose copy of each other, and two users exist on my PC. User 1 tries to access data, it comes from file 1. User 2 tries to access the data, it comes from file 2. They will get the same data, right? But if you will make changes in file 1, then user 2 will get old data and user 1 will get latest data from file 1. So this is what the changes will not get reflected in file 2. Hence file system is not aware about redundant data, duplicate data, and no guarantee of consistency across the redundant data, same data, right? Data sharing and concurrency. Now the second most important con is ki DBs can share the data easily because of one centralized place, and on files there is no isolation. See, in databases, the way the data is stored, it can be shared. You can make views on top of your databases, right? We'll come to that view, admin view and all. But the thing is ki you can abstract out more things on top of databases, right? If multiple users are reading, making changes into a file, there are some chances of anomalies where DBMS provide locking mechanism. It will come later in ACID properties. See, it's written here. But what does it mean is ki that let's suppose you have a file and multiple users are accessing that file, right? Though we have locking mechanism, like we can implement the locking mechanism in file system, but file system is not meant for that, right? So if multiple users are accessing a file and making the changes, anomaly is basically, what does that mean is ki some inconsistency can occur, right? So databases, they have locks at their database layer itself. So if two users are accessing the data at the same time, then database, due to ACID properties, right, consistency, atomicity, due to this databases have lock mechanism. We'll come to that. And due to this there will be less chance of anomaly, right? Data search and integrity. So DB provides simple queries to search data. So basically in file system, as you have already seen that let's say I have tons of file in my system and I want to query a file, select all the files where my file include, let's suppose, text student. It's not possible, right? There is no query engine written on top of file system, although there can be, okay, endless possibilities are there. There could be a query engine out in the market, but the thing is, if you'll go and think about it, that the structure of the data is such that in file system the queries will not be optimized, right? And according to me, it will take a lot of time, okay, even if the query engine is there. So data search and integrity in databases, due to the structure, due to the index and hash, all these things, the search of the data inside a million of records is easy. right? And you can not apply constraints on the files also, right? Let's say in my DB, I want some value to exist, but I want that value only present when it is non-null, right? So in file system, it's not like that. You can't put constraint. Let's suppose I want to put constraint on my age. I want to store all the students if age is more than 5 years, right? For my database. Let's suppose my database is of primary school. So that's how you can put constraints also. You have more control over the data in databases, right? While in file system, you don't have. So others miscellaneous things are key system crash recovery. You're editing a file and your system crashed. Then what about your backup? What about your replication? All these things, right? Okay, so this question was important. Why not file system instead of databases, right? So couple of cons I have already mentioned. Okay, now the applications of DBMS, as you already know that most of the enterprise applications have databases, and that too are in relational database. And few of the examples are ticket booking, right? Why ticket booking? Because why ticket booking? Because see, railway tickets has users, has tickets, has trains, right? So the relationship, and if you are booking a train, right, and you are booking a train in emergency window, there is something called emergency window. And if you are booking a train in emergency window, your app has to be, fast, almost real time as it should be, right? So it will fetch the trains, like it will fetch seat, right? How many seats are vacant, how many trains are there for your location A to B. So all these things we need almost real time. So we want good search capability, right? We want fast retrieval. All these things are offered by DBMS, databases management system. And similarly financial data, as you already know that if you want to, although it can be through any mode of communication like sockets and all, but the storage of persisted data, right, the persistence of the data which is all not volatile, that is stored into DBMS, right? Similar for e-commerce, similar for patient record, healthcare, etc., right? Now this question is very important. What is the 3-level architecture of DBMS? So whenever you give any interview or online round in MCQ, you'll get this question, okay, most of the time. Because see, this is very important. Why? Because see, every computer program or programmer wants abstraction. And nowadays, why LLMs are more liked by the developers is because of its abstraction. It provides so many things and you don't have to learn anything, right, under the hood. So DBMS, for DBMS, same, that people used complex data structure which is hard to directly interact to. So under the hood, the data structures that are being used in DBMS is hard, okay, are hard. Hence, to make retrieval, if you have to know the data structure, see what data structure I should use to retrieve, what data structures are used when I'm storing. So this is very hard, very complex, right? So that's why there are couple of abstract layers. So first layer is internal level, second is conceptual or logical, third is view level or external level, right? So here you can see the first layer is, you can see internal layer, logical view, external view, right? So goal of 3-view architecture is, so there are 3 goals. This will not be asked mostly, but for your information that why this abstraction is there in place is key, because user should be able to view the data without accessing the low level details. What does I mean? That mean is key, let's suppose as normal user who only knows about spreadsheet, right? He should be able to observe the data like a spreadsheet, right? A very simple view. He should not know like array is used or map is used, right? He should not be aware about this. And the second point is every user can have a customized view. See, now in my company, let's suppose I am a developer, someone is from analytics team, someone is from product team, right? There are some details that you have to hide from analytics team. There are some details that you have to hide from developers or product managers, right? So all these customized view, let's suppose I have a student table, right? I have student table and I have student ID, I have student login ID, and I have a student password, right? This is student, let's suppose login dashboard ka data. So this password I only want to show this password to developers, because for if they wants to debug and all, that too encrypted password, right? This column itself I don't want to show to any analytics team guy. So what will I do is I will make a view out of it. a customized view that will be accessible to the people who I am, giving the access to, right? Like analytics team. So that's how every user should be having customized view. That is the second goal. Because of abstraction, it is possible. Okay. Database architect, like the guy who work under the hood, is ki if he's changing the array or data structure, whatever the data structure is used, any buffer, whatever the nature of data structure was there, if he is changing that, the topmost user who is a very normal guy who only understands spreadsheets, he should not be able to see any clear difference ki okay, someone behind the scene changed something and I even don't know, and my spreadsheet is messed now. This should not happen, right? So this is the goal of abstraction. So physical layer, logical layer, external layer. Physical layer is basically, let's suppose where so basically let's suppose for customer table, right? And customer of any shop or any shopping mall, let's say, the records are stored in the files on which disk, right? This is one of the way to address physical layer. And DBA also wants to understand how the indexing is being used, right? How indexing is used. This is also the another way, like how B+trees are organized, what data types, how many page size you are using. Mostly on Linux and all, 4 KB is the page size. What is page size? We'll come to that. Then logical. Now the logical layer guy, how he will see the database ka overall scene. He will see the customer is an entity, right, with customer ID, name, and with other attributes. He will define the data types and keys. He don't care about how indexing and hashing is used in under the hood, how B+trees are organized, etc, etc, right? External, the topmost guy, he only knows that, let's suppose a sales guy, sales point of view can show customer ID, order amount, that's it. Shipping point of view can deal with name and address. These are the business people who are dealing with our database. They don't care about anything else, any other layer. Talking about the database evolution, you can pay attention to this because sometime if a question, if a interviewer wants to question you, just a tricky question, he will ask on hierarchical. Ki there is a hierarchical database. He will explain you ki in hierarchical database this is A, B, C, D. These points are applicable. Now we are in relational models. What differences do you see? The clear differences that you can see among themselves, right? So, and in general also you should know how database evolved. So first of all, before the evolution of entity relational model, the model that will come to, and we'll design a database also for Instagram. So ER model, in entity relationship model, we have different data models to store the data, right? First model is hierarchical model. This was built by IBM and still is in use. I think it's called IMS I think, in 1968, and the data is stored in tree format, which each children having one parent. So the redundancies here I will explain you. So let's suppose electronics table is there, right? Electronics could be of many types, and we have taken televisions, portable electronics, and television. From television itself we have two categories, LCD, plasma. And for portable we have MP3, we have CD. For MP3 we have flash. So this is a kind of parent-child relationship. Advantages of this kind of database is how this data will be stored. Don't worry, it will be, let's suppose, electronic ID, right? Electronic name. Here it will be television ID, a tuple only. Okay, television ID, name, warranty, price, etc. So tuples only, records. Now these tuples could be organized using any data structure that we are not focusing to. So the overall structure of the database is like this, right? And it's very simple. It's not too complex to understand the structure of your database, and retrieving one-to-many data is easy and efficient. See, one-to-many, why I'm saying that is, let's suppose television is an electronic, right? And television also comes in gadget. So here one child couldn't have two parents, right? Otherwise it will become many-to-many. So what does one-to-one, many-to-many, one-to-many, many-to-one means? Ki you have two sets. One set is here, one set is here. You have elements A, B, C. Here you have element D, E, F. It is one-to-one if each element is marked to another element and uniquely, right? It is many-to-many if it is okay, controls is not working. A, B, C, D, E, F. So like this, right? So here you can say that one parent can have one child can have one parent. Okay, one parent can have many child. So one parent, many child, so one too many. So if I am coming from top to bottom, one parent can have many child, so one parent could be mapped to multiple things. So that's why it's one to many mapping, right? But the opposite is not correct. If opposite is also correct, then it will become one many to many. So it's very simple to retrieve one to many data, because if you want to retrieve flash, right, you will go through television, right, electronics, you will go to portable electronics, you will go to MP3, you will go to flash. That's how you will retrieve. Now, disadvantages. Incorporating complex data structures is difficult. Obviously, you can see that if I want to incorporate a student who belongs to a teacher, who belongs to school, so a student is a child and there are two parents. So to represent this data, what you have to do is you have to maintain something called two trees. One tree is for, let's suppose, teacher, how teacher is related to student and how student is related to class and all. And then another structure is, because see, hierarchical is only able to hold the data which is of one to many type, right? Now another thing is school to student. So now it is called redundancy. Why? See, here let's suppose any student S1 is present, here also that student S1 is present. Now this S1 is duplicated here. That's what we call redundancy. And consistency is also not there. Let's suppose S1 is terminated. This student is removed from the school. So I am deleting here, and somehow I have to delete the data from here, and there are high chances of inconsistency occurring if your student is duplicated at multiple places. So that's one of the disadvantage. Network data model. Second model is network data model. Here it is similar to what we have discussed just now, which is hierarchical. It's just that it is holding many to many relationship. That's it. So this is also, I think, in IMS from IBM they made network. You can search about it. But network data model is a directed graph or network of different records. Multiple parents and multiple children can come into your concept. So basically a project, students started a project, and a sub project, project 1 belongs to project 2 belongs to project, and then there are departments. Let's suppose department 1, department 2, department 3. Department 3 can have department 3 is having project 2, project 1 both. Department 1 is also having both project, and department 2 only have project 1, right? So here if you will pick any children, department 1, it has two parents, right? It has two parents. And if you pick any parent, it has multiple child. So parent to children is also multiple relations is possible, and children to parent multiple relations are possible. So you can say many to many relationship is possible here in network data model. It is very similar to hierarchical, just that the more flexibility is there. Disadvantage is complexity increased. See, I want to check department 3 project. Okay, so there are multiple ways. First I have to explore, okay, this is a project started by this is project started, and project 1 is started under this project. Let's suppose this is a government something fund, which is a project from government, and we started some, let's suppose robotics something, project 1. Okay, and this belongs to electrical engineering department. So now government fund is related to robotics is related to electrical. Fine, well and good. But this is also related to AI. Project 2 is AI. So I have to explore all the paths. So the people who know data structure a bit, they know breadth first search and they know depth first search. So here in the top thing, depth first search is possible, and it's very straightforward. We'll get only unique path, right? One path because of one to many relationship. Here you will get multiple paths, and complexity has been increased obviously, and with time you can assume it will become a forest, not a tree. It will become a forest, and to explore all the things in a forest, it's a very hard task. It's a very brute force way, right? So it's not easy to work with as a user. Okay, now the third model, the OG model, is relational database model. So here the database, you can visualize the data structure in a kind of in a way of tables, right? The tables are 2D matrices where you have columns, right? Here you have columns: student ID, student name, student address, birth date, and student's gender, right? So this is called, the number of columns is called degree. So degree of this schema, or relation is 1 2 3 4 5 around 5, right? Yeah, 5. So, and the cardinality, see, these two terms are very important. See, whenever you will get MCQ in your online assessment, most of the people talk about cardinality. They will not say ki rows, right? And number of rows is basically cardinality. Or sometimes people say number of unique rows is also refers to cardinality, right? Let's say the gender of the person, the sex of the person is only possible male, female, that's it. Okay, male, female, and the cardinality people can say is 2 because of 2 unique values. Or you can, in general, for the overall table, you can say cardinality is the number of rows, right? So these are the data values, right? These are the data values. See, IDs are integer, data values are string, this is date, this is enum or string. So data values can be represented like what is the data value, what is the default value. So data value is string, default value is null. Default value means whenever you are inserting something, a record in your database, and that student address is not available, right? Or that student birth date is still under progress or whatever, that value could be stored as null. So that's what we meant by default values. Advantage: high data independency and flexibility. So basically now the data, you can retrieve the data. There is no dependency, strong dependency that you have to retrieve. Like in network data model, you have to go from A, B, C, D. Only then you will be able to check how D is coming in place from A, right? Here you just have to, search a couple of rows, depends on some if else. Let's suppose if gender is male, if student birth is under this range, find the student where name is like this. So the structure allowing us to make the query such a way that we are able to understand the queries, right? The second advantage is remove duplication by what normalization is. We'll understand, we'll discuss, but something is there due to which we will remove the redundancy. Means if student is present in table 1, this is a table 1, and the same student is present in table 2, is there any way to merge the tables or to abstract out the student so that I don't have to make the change in both the table whenever student is updating his information, right? So yeah, so you can use normalization. What normalization is, we'll come to that, but normalization is just that you are giving your tables good flexibility, and on the parallel ways you are giving it basically consistency and non-redundancy, right? So disadvantage is complex for straightforward search. Now my straightforward search is retrieve a person whose name is Lovepreet. Very straightforward, but I have to go through a number of rows to check that, right? Now the second thing is needs deeper understanding of normalizations, queries, right? So this is one of the disadvantages, that you have to understand normalization. If you don't know normalization and while designing your schema, you will end up in race condition most of the time, or inconsistency, most important inconsistency in your project when it will go to production, right? So yeah, so we'll discuss about entity relation model, we'll discuss about ER, we will discuss about EER. So ER is entity relationship model and EER is enhanced entity relationship model. Both are very important. There are some company startups who ask specifically about ER model design, your database design, and you have to just design a ER model diagram. Okay, so ER model follows entity relationship presentation, right? That can be used to represent any kind of DBMS schema. So this is theory, like ER is just that entities, there are relationship, and you just have to draw that, right? And why ER diagrams are preferred at the very first place instead of directly going to the database schema, because ER diagrams give you the relationship in irrespective of SQL or no SQL, right? It just tells you that if your data, whatever you want to store, if that data is related to, if let's suppose data D1 is related to data D2, is there any relationship existing? If there do exist any relationship, then obviously ER diagrams help you to understand how your database schema should be designed. Second thing is there any relationship which is so generic that you can go to NoSQL database? Okay, SQL is okay. For the people who don't know, SQL is just, you can as of now, you can assume SQL as relational. See, tables, structure. NoSQL is just that a file is there and all the data, let's suppose your student name, ID, class, everything is being put into that file. That's it. Okay, yeah. So there are some symbols, there are some representation that you have to remember. Obviously there are some things you have to remember anyway. So while designing ER diagrams, you have to remember these symbols. First one is rectangle. So whenever there is entity, what is an entity, will come to that. Entity is being represented by rectangle, and the attributes are represented using ellipse, right? And the diamonds represent the relationship among the entities. Line is just to attach something, very simple, doesn't matter. A double ellipse is multi-valued attributes. What is multi-valued attributes? We'll come to that. Double rectangle is weak entity. What is weak entity? We'll come to that. So ER model is about these things only, and that's it. Entity could be of two types. Weak entity, you have already seen that it's like this double rectangle. Strong entity is just rectangle. Attribute can be a key, right? Let's suppose my name, a composite key, composite name, sorry, a multi-valued, a derived, right? We'll come to that, don't worry. Relationship could be one-to-one, right? A student is related to teacher, and student could be related to many teachers, right? One to many, many to one. Many teachers are related to one student, or many to many. All teachers are related to, no, many teachers are related to many students, right? More than one. So entity is an object or real life thing that has existence. See, whenever you are talking about anything, let's suppose I am talking about here it's written car, student, merchant. Let's suppose I am talking about my company, right? Let's suppose, or I am talking about, let's say, a stadium, a cricket stadium. In cricket stadium, what are the entities? So first of all, what is your use case? My use case is to represent the stadium, the cricket people, the audience, right? So there is something called entity, right? So entity is physical object or physical things that has some existence or that could be related to someone else. Now the first thing is, one of the entity is a normal person. Person is an entity who is a player also, who is present in audience also, right? So he could be in playing field, or he could be in audience stance. So the entity is person, that's it. Now the person could have multiple things, right? A player, a audience people, or a water boy, or whatever. Now the second thing is ki I am talking about the strength of people, right? Again, that involves people. So my use case will always revolve around the people in the stadium, right? And the stadium itself, stadium is also an entity. Why? Because stadium has properties. What properties? Stadium has its location, stadium has its size, stadium has some capacity to hold some people, right? So there is relation of this stadium with something else. So a entity is kind of a object that either is related with something or either a physical entity, right? Strong entity doesn't depend on another entity. See, strong entity doesn't depend on another entity. The very good example is ki, let's suppose your company is storing employee information, right? And the company is also storing employee spouse information, right? Let's suppose this employee is male and his spouse is female, right? Now when employee resigns from the company, this entity wouldn't make any sense. Why? If the employee is not there in my company, I could mark this employee as ex-employee, right? Or I can just delete this employee itself from the database. Now this entity is a loose entity. This entity has no existence without its parent, which is the employee itself. So this entity is a weak entity and I have to remove this entity, right? So weak entities always depend on something else. Strong entities can exist on their own. They don't need anyone else's existence, right? So weak entity can't exist without a dependent. The relationship between weak entity and its identifying strong entity is called identifying relationship and represented by double diamonds. So see, a company storing employee dependents like spouse, children. Employees dependents can't exist without the employee, because company, the main entity, is related to employee, and that employee is the first and foremost importance, right? And all the dependents of that employee are related to employee only, then that's it, right? So these dependents are related to this employee and they haven't have any existence without this employee. So that's why this is called weak entity. right? This is anyways a strong entity. And if you want to represent, although there is no need to represent a relationship because you know that employee and dependents, but yeah, relationship would be weak relationship. Attributes are the properties that one entity has. What are attributes? So my address has attributes, right? So again, don't think about the tables when you are drawing ER diagrams, right? Because ER diagrams, the main goal, the final goal of ER diagram is not to make SQL or NoSQL tables. It's about to identify all the relationship that your DB has, right? So that after building all the relationship, you can decide if you want to use SQL, if you want to use NoSQL, or what exactly the schema of your DB is going to be, right? So that's why ER diagrams are there, right? So don't think about the tables and all. So let's switch to attributes. So whenever my address is there, my address has attributes like city, my street, my state, my country, my house number, whatever, and that is called composite attribute. The attribute that is made up from multiple things, right? My name is made up from first name, last name, middle name, right? So the key attribute which uniquely identifies a entity. So if my student table has roll number can uniquely identify my attribute, my entity, and that attribute of my entity is student, attribute is roll number, that attribute is called key attribute, and it is represented by, this is attribute anyways represented by a underline, right? Multi-valued attribute, again phone number, the attribute having more than one value present in an entity. So my phone number could be like my mobile number and my, let's suppose, second mobile number. So this attribute can hold multiple values for the same user. So this is called multi-valued attribute, and the attribute, multi-valued attribute, is represented with double underline. Derived attribute is age. Derived attribute is the attribute which don't need any storage, right? You can just derive. How? Age can be derived from my date of birth. Age can be derived from my date of birth. So if my date of birth is being stored in my entity, let's suppose entity is person, and person has attribute DOB, then age will be a derived attribute. Why? Because I know the today, I know the latest time, right? I know the latest time, right? And I know my age, right? So I can check how many difference of years or months or days is there, and I can derive the age attribute. So age attribute can be derived, right? So student attribute, student entity, the complete student entity is here. So the entity is represented by a rectangle, student entity. What are the attributes? Name is a single valued attribute. Date of birth, right? Phone number, now phone number can hold multiple values, so that's why it's a multi-valued attribute. Age can be derived, so derived attribute. But before saying age is a derived attribute, check if DOB is there. If age could be derived from the existing attribute, yes, then mark it as a dashed attribute. Then address is a derived attribute, right? Address is a multi-valued attribute. See here composite attribute, multi-valued is phone number and derived is age. So address is a composite attribute which is made up from state, city, street, country, right? And so this is the complete entity for student. Now coming back to the relationship type and relationship sets. So degree of relationship, there is something called unary relationship where one entity set participating in a relation. So basically a person is married to person, right? There doesn't have to exist any another entity. Like let's suppose there don't have to exist another person will marry to person, right? So it could be like, it's like you have a person entity, right? Relationship is person wants to marry something, or a person is married to someone. So what we'll do is the relationship is married to, right? What does this mean is, this means a unary relationship, right? What is a binary relation? Most of the time you will deal with binary relationship when two entities participate in a relationship. So a student is an entity, a course is an entity. So a student is related to a course with relationship enrolled in. If this is not a student, and this could have been, let's say, teacher. Now teacher teaches the course. The enrolled in relationship will only be in student and course, right? Similarly, ternary relationship and array relationship, whatever. Cardinality. Now this is how you can represent the cardinality, right? This. So one employee can own only one laptop. So employee is an entity, laptop is an entity. Now employee can have attributes like name, age, right? And laptop can have attributes like suppose warranty, right? Date of issue or whatever, right? So one employee can only own one laptop at a time. So relationship is owns. Now if relationship is owned, so first you have employee, second you have a laptop. So you know the entities. Now you have to make the relationship among the entities. So the relationship which makes sense is employee owns laptop. So now you have identified entity relationship. The third thing is if there is any weak entity or not, if etc etc. Last thing is if what is the cardinality of the entity, right? So the cardinality is one employee can own one laptop, so 1 to 1. Now the second is you have CS department, you have professor, right? So CS department entity has professors. So one CS department can have multiple professors. That is true, but multiple professors can not have multiple departments, right? So what I'm saying is now it depends on the situation you are designing your database. It is very highly dependent in your interview what you are working on. Now if I'm working on a college database ka ER diagram, I'll tell the interviewer that my assumption is that CS professor can't teach in civil department, right? According to that assumption, my relationship is 1 to many. Now many to 1. So multiple surgeries, single surgeon. So multiple surgeries can be done by single surgeon, but single surgeon, or the other way around, single surgeon can do multiple surgeries, right? Many to many, one employee can have multiple projects. Multiple projects can be owned by multiple employees. So let's suppose 3 employees are working on one project and 2 projects are owned by single employee. So it's many to 1, 1 to many to many to many. So you can read more about many to many relationship, but it's just that understandable that if employee and projects is there, so multiple employees can work on one project and multiple projects can be owned by one employee, right? So from you will just go left to right, right to left. From left to right, multiple employees can work on one project. Multiple projects can be owned by one employee. So it's many to many. This is how it works, right? Now the last thing is, I think, participation constraint. So there is total participation and there is partial participation. Total participation is that your entity is student and your another entity is course. Relationship is enrolled in. Now the cardinality is M to N. Multiple students can enroll in multiple courses and multiple courses can be enrolled by multiple students. So yeah, enrolled in is M to N or many to many relationship, but it's a complete or total participation of student entity. So you are a student in this relationship and you have to enroll into at least one course. So any student into this entity, S1, S2, S3, every student has to enroll in some course. So all the students will have the participation in this relationship, and that's called total participation. And it's partial participation if the course is elective. Let's suppose the course is elective, then it is not necessary for all the students to enroll that course, right? So that's how it will become a partial participation, and partial participation is just mean that like a single line, and the total participation is double lines. Okay, so that's about representation, that's about drawing ER diagrams, that's about relationships, cardinality, type of relationship, etc etc. Now comes the concept of there are some more concepts of enhanced ER diagram. Then we will come to Uber diagram, ER diagram. Then we will design Instagram, and we'll design that live only like in today's lecture. So coming to how to draw ER diagram. So whenever you are going into an interview, so make sure the very first step is identify all the entities. So note down these steps because you have to follow the steps according to this only if you are drawing any ER diagram. So first of all, you have to identify all the entities. So whatever, let's suppose you are designing Uber. So Uber ride system, ride hiring system, if you are designing, you have to identify all the entities. According to me, the entities could be ride, the person, the rider, the customer, vehicle, location, all these things, right? Location could be an attribute, yeah. But yes, you have to identify all the entities, place them in rectangle. Now the next step is identify all the relationship and place them in diamonds. So what relationship you can see from your requirements, place them in diamonds, then attach the attributes. Like for a rider, what could be the attribute? His license number, right? His name, right? His, let's suppose, DOB, his Aadhaar card number. So all these things like attributes should be placed inside ellipse. Remove redundant entities. So after a point of time when you will be done with your entities, with your relationship, with your attributes, you will see that you might have drawn something which is redundant, which is duplicate. So you can remove the redundant entities or relationship which doesn't make sense or either duplicated at multiple place. You can remove them, and then at last add cardinality, add relationship, add participation. That's it, right? So before going to designing something, we want to discuss EER. So enhanced entity relationship model. Why EER came into the picture is because, see, there is something called subclass, superclass, specialization and generalization. Heavy words, fancy words, doesn't, it's not too complex. So basically in ER model we have entities, right? We have attributes, we have relationships. Three things we have. Now EER, enhanced ER model, we have subclass and superclass. Doesn't make sense, right? Because it's very normal thing. Specialization and generalization, category, attribute and relationship and inheritance. We'll talk about it. So what is subclass and superclass? So when your entity is science, right? When your entity is science, let's suppose your entity is science, right? Now this science entity can have physics, chemistry. So these are just special version of your normal class. So if you have done object oriented programming, you would know ki parent class is there, children class is there. It's very similar to that only, right? Now this generalization and specialization is highly linked with this subclass and superclass concept. How specialization is a special or subclass of a generalized or a superclass. This is usually is a relationship. See, over all these things, this thing is a most important one, right? Is a relationship. Like laptop is a computer, developer is a employee, right? It is inspired from object oriented programming. So let's say you have one table. Now I am talking in table, but you should not. And it is storing number, name, salary, tuples. Okay, this is the first tuple, this is second tuple or record, this is the third tuple. Now this employee have two special classes, which is tech department employees, customer success employees. All of them have similar things: number, name, salary or rating, right? So it has some other attribute, typing, because tech department I want to track their typing, for customer success I want to track their behavior, kind of key metrics. But both of them have these things common: number, name, salary, right? So common things I have abstracted out, right? Let's say I am not abstracting these things out. Let's suppose two tables are there: tech department, customer success. Then I have to duplicate the things, which is name, number, salary, number, name, salary, right? Instead of that, I have abstracted out number, name, salary out of these two tables, and I've taken those three attributes out of those tables and made another table which is employee. And now this is what we call as specialization or generalization, right? Now people could argue that what is the difference between specialization and generalization? See, there is no difference. If you want to go in deep depth, there is a difference. But for ER diagram, for drawing ER diagram, you should consider that it as a superclass or subclass. That's it. Here it is actually a generalization, and from right to left, if you will see, it is a generalization. From left to right, if you will see, it's a specialization. So it's a kind of process you have taken to abstract out. Doesn't make sense. It's just parent class, child class, right? Multiple inheritance, which is union. A subclass can be a subclass of multiple classes, or an entity can belong to multiple entities. In this case, attribute or subclass are the union of all superclass. Doesn't make sense. Why? Because see, if you are designing your ER diagram this complex, then either you are making some mistake or your application is very complex. So what is it saying is that, let's suppose you have employee, right? you have address, you have employee, you have address. Let's say I'm just taking an example, and you have a tech employee. So tech employee is also an employee. Tech employee is also having some address, and in address, street, city, all these columns are there. Employee name, number, salary is there, and in tech, typing is there. Let's suppose. Now what it is saying is union. What does union mean is ki when I want to fetch any tech employee, its attribute will be tech employee attributes plus employee attributes plus address attributes. Why to generalize this too much? This is too much, right? So I have just told you what union means, what multiple inheritance. Someone could ask that is there multi inheritance possible in ER diagram? You can say yes, and this is the case, or you can think more about good examples. But when you are designing the ER diagram, make sure you don't do this, right? So designing ER diagram of Uber hiring system, you will design this ER diagram today, right? And in next part of the course, you will complete acid properties and every depth of B plus trees, because that is complex kind of thing. And I think if you have come this far in this course, and you would have understood most of the things, and in next part it will go little up the way, right? It will not too basic like today, but still from overall our DBMS course, this is one of the most important thing, ER diagram. Second most important will be SQL. Third most important will be acid properties. Last and not the least is this B plus trees, hashing, indexing, right? Okay, so first of all, the interviewer. Okay, now this is a kind of mock interviewer. Interviewer will ask, we have to design Uber ride hiring system. So then what I will do, I will first of all collect requirements. So I will list down the requirements. I will type that user should be able to create his profile. So under under the hood, I will think about how Uber works, how today Uber works. He could have told me that we have to design Uber like ride hiring system, right? Or he could say we have to design a photo sharing app like Instagram, right? Think about Instagram only, think about Uber only. I am downloading the app today. What I will do, I will create my profile. So first requirement, user should be able to create his profile. Second thing is, after creating my profile, I will try to book a cab or ride. So user should be able to book a cab or you can say ride, right? Third thing what I will do is I will pay after completing my ride. So what will the third requirement is that user should be able to pay using any cash method. Think about it, right? This is how you will use the app. Then the last thing is rider should be, now switch your gears, right? So if I'm talking about my Amazon system, I will first talk about as a user, I should be able to create my profile, I should be able to see my orders, I should be able to order, I should be able to search this, that. And then when my requirements are done, I will ask the interviewer, do I need to design for the other person, which is merchant on Amazon. Similarly on Uber, I would not ask, because the requirements are already very less requirements are there. But if requirements are going out of the boundaries, let's suppose you have come up with 10-15 requirements, then you should ask the interviewer that can we pick this top 5 requirements first, right? So my requirement is rider should be able to accept the ride, and rider should be able to accept the cash from the passenger. So these are the requirements, right? So go through the requirements. What are the entities that you can see? The user is there, the rider is there. Both are the entities, right? Both are the physical objects. They should have, from the user point of view, they should have rating, they should have name, they would have something called number of rides. Let's suppose, okay, from user point of view, number of rides doesn't make sense. So from rider point of view, license number, Aadhaar number, rides completed rating, all these things. So first entity is a person, right? Now I can specialize this entity, which is user and rider, right? Now the second thing is my next entity is vehicle, right? My next entity is payment, and next entity is ride. So why I have made payment and ride as an entity? See, I've already told you, either your object is a physical object, so there will be a high probability that if your object is a physical object, which is a person or user or rider, then that object would be related with your system, right? Now the payment, is payment a physical object? Not necessarily, but is payment have some attribute? right? Does payment have some attribute? Let's think about it. Now payment could be through cash, through UPI, right? But is it related? First thing. Second thing, does it have any attribute? Attribute it has, like payment is made on some date, payment is of some amount, right? Otherwise, if you are not storing payment, you will store amount in your user table, you will store same amount in your rider table, which doesn't make sense. So that's why payment is a entity, and because first of all it has some attributes, second of all it is related to our user, it is related to our rider, right? Similarly, ride. See, ride has some attributes like drop location, like pick location, like ride time, and it is related to our user and rider. Now comes the point ki if you are the person who is designing this ER diagram and I am the interviewer and you have missed the ride entity, will it hamper your progress as you will draw ER diagram? No. See, when you will draw the diagram, you will come to know that now you have to store, let's suppose user is booking a ride. You have to store the locations from where he booked a ride. Now that user is an entity. How you will store the ride? And there is a rider. Would you say that user is hiring a rider? Yes, you can do that. Now the attribute of pick location and drop location, what you will do? You will store pick here, you will store drop here, and same thing you will do here. Now you are the person who forgot about having this ride entity in your system, and then you went ahead with vehicle, payment, user, rider role. And while designing, you got to know that user and rider both have these attributes, which is pick and drop. What you have to do? Just abstract these attributes pick and drop because these are commons to user and rider and make them as ride, right? Now user and rider have the relation with ride, right? Now user book a ride and rider accepts a ride. These are the relationship. And now ride will have both the attributes drop location and pick location, drop location and pick location, right? As simple as that. Relationships. Fine. Now the next thing is, after doing this, after collecting the requirements, after defining the entities, find the relationship. So the relationship is user is a person, right? I have already applied specialization in my mind though. Rider is also a person. Rider accepts a ride. User requests a ride. Rider and user make a payment at ride completion. So this is the relationship. And again I am saying, if you are the person who has, let's suppose, another kind of relationship, doesn't matter. It doesn't matter. See, in ER diagram, in low level design, in high level design, there are multiple possibilities, and only thing you have to have in your mind is that there should be at least one reason why this thing exists, right? There is a reason. Rider and user makes a payment at ride completion. Why? Because ride is completed. What do you expect from after completion of ride, right? So yeah, there is a reason. Make that a relationship, right? And it doesn't have to have like my relationship that I have made here. It doesn't have to be like that only. Now the next thing is you will draw and everything, and you will define the cardinality. So first thing, I will define person, right? Person, very generic thing. Person will have attribute like onboard date, when that person onboarded, doesn't matter, user, rider, whatever. We have person ID. Now person ID is just a incremental ID, like first person came into my database, its ID is 1, now the second person had 2, 3, so it's unique. So I can identify this person using PID attribute. So I have put an underline here. If this person has name, this person has DOB. Now DOB is here, so age will be a derived attribute. So this is a derived attribute. And this person has profile picture. Now this profile picture is a URL, and this URL is made up from name. Let's suppose this person profile name is http my base URL /name/dob/whatever, right? Let's suppose some another URL. So this complete thing will make my profile picture ka URL, and that's how I've introduced name, DOB, URL. On the go, I am defining the attributes. Person. Now rider is also a person. You will make a rider. Now rider have rating specific to the rider, right? Rider have ride ID. Rider have number of rides completed, rider have KYC completed or not, the data type will be boolean, rider has license. Now the next attribute I'll make, entity make user, user has user ID, user has rating, user has ride, number of rides requested. I have payment, payment has date, amount, type, payment ID. Similarly ride, ride has ride ID, ride has pickup location, drop location, ride time. Now drop location and pickup location is a derived attribute and it can be derived from composite attribute. Again and again I am confusing you guys, sorry. It is a composite attribute that can be composed from multiple things. Derived attribute is age, right? Okay, pickup location can be composed from street, city, house, and drop location also city, house, street. Don't think about tables, nothing else. Just think about entities, their attributes, their relationships, right? Now vehicle. Vehicle has vehicle ID, vehicle has type, let's suppose 2-wheeler, 4-wheeler, vehicle has license number, vehicle has registered date, right? Now all the things we have identified, right? We have identified your entities, your attributes, right? And the type of attributes like multi-valued, like derived attribute, like composite attribute. We have derived attribute here, age. We have composite attribute like profile picture here. We don't have any multi-valued attribute though. But if user has phone number, then user can have multiple phone numbers. But again, you will think, let's suppose user have phone number here. Phone number. Is it a multi-valued attribute? Think about it. Now, if I could have been into my school database, I could have marked this phone number as multi-valued attribute. Now, in my Uber account, I will say that to the interviewer that, sir, this user can have phone number and similar for the rider. But this user in my Uber system, I am assuming that one user account, which is user ID, one user ID or user account can have only registered to one phone number and that's it, unique. So in this case, in Uber system, my phone number will be single valued, not multi-valued. Right? So this is how your ER diagram will change according to your use case. Now the last thing is you have to identify the relationship, and before that you have to make sure this is a generalization or specialization ka symbol. You have generalized the person into rider and user, or I would say if you go bottom to top, rider and user have some common attributes like name, onboard date, and etc. You have abstracted those components and you have put that attribute in person, and from bottom to top you have generalized something. So you will attach rider, user with person with this diamond shape, which is called generalization, right? Now comes the relationship part. So this rider, so first of all let's complete user. So user is related to payment. So all the entities I will iterate through: user payment, user ride, user rider, user vehicle, everything. User makes a payment, so relationship is make, right? Second thing is user request a ride, relationship is request. Just attach single lines at first, single line, single line, single line, and then user is related to person with the generalization. That's it. Now to complete the user, I will check one user can make multiple payments, but one payment could not be made from multiple users. Right? A user is paid 10 rupees. Basically, user can have multiple rides in one day. So he can make multiple payments, right? So the relationship is one to many. Now this is your homework. If user or payment, first check user. If user has complete participation in the relationship, or if payment has complete participation in the relationship, if both has, you will obviously make this line as double line, double line. If one of them has, let's suppose every user make at least one payment, means every user in this entity will have relationship with a payment, then you will make only user ka line as double line, which means total participation, right? That is your homework. Now user is related to ride as request. User request a ride. What is the cardinality? User can request multiple rides. Yes, user can have multiple rides in a day. Multiple rides. One ride can be requested from multiple users? No. एक राइड में मल्टीपल यूजर्स नहीं होंगे. एक ही अकाउंट से यूजर एक ही अकाउंट से वो राइड स्टार्ट होगी, एक ही अकाउंट से वो राइड खत्म होगी. सो इट्स ऑल्सो वन टू मैनी. So similarly, rider accepts a ride, vehicle belongs to rider. So now here you can see all my system will only store the vehicles of the user which are related to rider. I will not store all the vehicles in my city Bangalore, right? I will only store the vehicle in my system which are related with rider. So that's how you will communicate to your interviewer that I'm assuming that all the vehicles I am deleting. Let's suppose a rider deregisters or delete his account. I'm also deleting all the vehicle related to that user, because from my database I don't care, right? So all the vehicles that I have in my DB which belongs to rider, they will have complete participation. So one rider can own multiple vehicle, but one vehicle can't be owned by multiple riders. So one rider can own multiple vehicle, right? He could have Activa, bike, auto, cab, whatever. But one cab can't be owned by multiple users. That's how my Uber car DB design is putting constraints. And then again, another relationships are there. Rider accepts or payment is accepted by rider, whatever, right? So I will attach all the notes in description, don't worry. So yeah, so first thing is check the entities. Second thing is draw the attributes. Make sure you know the attributes ka behavior, like multi-valued, composite, single, all these things. Then make sure you know the relationships. So relationship are these are relationship. Then attach the relationship with your entities. Then define the cardinality and participation. That's it. Here you can see generalization, specialization. Generalization is a bottom to top approach of extracting out common duplicate attributes and putting them in generic class. You can see student and patient, they both are person. So this is how I am generalizing it. Specialization is dividing one entity to more than one specialized entities, and it is a top to bottom approach. So I have a bank account which has balance and account number, and this account can be divided into current saving account and saving account. So both of them will have account number, balance. Though in the tables they will have these attributes at account entity only. I've just drawn these attributes, account number and balance here also, but this doesn't mean that account number, let's suppose one account number 1 and balance is 1000 rupees for person, let's suppose U1 is also present here. It's not like that, right? I've just drawn these attributes here. So generalization and specialization both are the ways to make the things clearer, right? Generalization abstract the common attributes, specialization makes thing more clearer. But again, if you are confused about generalization, specialization, don't worry about it. Just make sure you know about generalization. That's the thumb rule, right? So that is our part 1 of DBMS in one go. In the next part, we'll start our DBMS in one go from designing Instagram. I will design the requirements. I'll write down the requirements. I'll define the entities. I'll define the relationship. I'll attach the entities with the relationship, cardinality, participation, everything. And then obviously your homework is to design the Instagram, and in comments you have to give the Google Drive or whatever link of your PDF or your image or whatever, right, where you have drawn the Instagram, and I will post them on Twitter or somewhere else, right? But make sure this is your homework and you share with me, and from the next part we'll design Instagram and we'll go to acid properties, normalization, and these concepts are a little bit complex than the topics that we have discussed. But till then, take care and bye bye.